Benvinguts a la conferència Gender Perspective in University Level Teaching and Physics and Engineering Subjects a càrrec de la doctora DANIELSSON, que com sabem és professora d'Educació Científica del Departament d'Ensenyament i Aprenentatge de la Universitat d'Estockholm. Sabem també que és especialista de reconegut prestigi en qüestions relacionades amb gènere, identitat i el poder en el context de l'aprenentatge de la ciència i la tecnologia. Bé, què podem dir des de la Universitat de Barcelona? Doncs que encara tenim molta feina a fer. La perspectiva de gènere ha de ser una realitat en els plans d'estudis i en els plans docents. Sí que volem dir que sabem que estem treballant-ho des del rectorat, la unitat d'igualtat, les comissions de les facultats, però sí que dels centres, perdoneu, però evidentment és una realitat que ha de ser cada cop més gran i que es faci com una taca d'oli, perquè realment, avui l'Anna ens explicarà també l'experiència en la seva universitat, però realment què hem de fer? Doncs bé, tothom hem de, tant a nivell d'institucions com a nivell de cadascú, ser autocrítics i valorar les subjects, les matèries, per si realment com podem millorar. I també l'alumnat, com l'alumnat també realment poder avaluar si s'està fent de manera correcta. Per tant, tenim molta feina a fer, però estem treballant amb això. Això també en som conscients. Per tant, jo només dir-vos que és necessari fer ressò de persones, dones referents en diferents disciplines, sobretot disciplines com física i altres carreres més tècniques que hi ha encara més homes que dones. Però realment és necessari en totes les disciplines, donar veu, tenir referents, fer molta difusió, encara és necessari. Donar les gràcies per a l'organització d'aquesta conferència. Doctora Estradé, moltes gràcies per fer possible que avui podem gaudir d'aquesta gran investigadora i docent. Professor Dr. DANIELSSON, it's an honor for University of Barcelona today explain your research. Thank you very much.
Thank you so much for that. In this talk, what I plan to do is to take you on sort of a journey through different physics learning contexts. We're going to start in lower secondary school. This is a schooling that has different names in different countries, but I'm thinking like 13 to 15 years of age. So that's where we're starting. And then we're going to go into higher education and also something briefly about professional physics contexts. And during this journey, we're going to stop on the way and pick up some theoretical concepts to help us kind of think about and conceptualize these different learning contexts. But don't be afraid, or some might be disappointed actually. It's not going to be a very theoretical talk, but I'm going to use some theory in the talk. But I would like you to start by thinking back to your lower secondary school physics classroom. As I said, a schooling that has different names in different countries, but last years of compulsory schooling, 13 to 15 maybe. That last time you were then probably taking physics together with people who had not chosen to specialize in physics. So what are your memories from classroom, from this compulsory school physics classroom? The classroom might in some ways be very similar to other classrooms in that school. Benches in rows facing the teacher. A room designed in a way to make communication between teacher and students easy, but communication from student to student more difficult. And there are also probably ways in which this classroom is different from other classrooms. Maybe it looks like something like this picture with like glass cabinets along the walls filled with laboratory equipment. What are you feeling in that physics classroom? For many of you here, if you come from physics, it might be a feeling of belonging, a feeling of success maybe even. When you, on the first try, got all those light bulbs in that quite complicated parallel circuit to light up. For others, if you look around in the classroom, there are likely also to be classmates in that classroom who are more looking dreamingly at the clock on the wall, wishing for nothing more than that clock to move just a little bit faster. And hopefully you and your classmates, whether you are successful in your circuits or looking dreamily at the clock on the wall, hopefully you are learning a thing or two about physics. But you're also very likely to be learning whether physics is a subject for you or not. And we know from research that in many schools, many students learn simply that physics is not for them. It's a subject that's generally perceived as difficult. We talk about physics as a hard science. And this predominantly refers to the subject, the knowledge being produced as hard, its objectivity, its neutrality, its rationality. And this, of course, but this also contributes to the idea of physics as hard as in difficult. We also see how physics is very strongly aligned with notions of intelligence, of cleverness, and also associated in many European cultures with man and masculinity. But why does physics seemingly do all this work to, it looks like, keep people out, simply? Professor Louise Archer at UCL in London and her research group, they argue that there is a pedagogic work going on in these physics classrooms. And the purpose of pedagogic work is the reproduction of dominant forms of privilege and inequality. So in the case of physics then, they further argue that we can understand the pedagogic work as being enacted within school physics in order then to maintain the status, the hierarchy of this subjects, sort of the dominant status of physics as a school subject. So consequently, classroom practices that, for example, then align physics with continuously sort of defer the interesting bits to later on in the curriculum, later on in that later course. They aren't just random or happenstance. They really, you could say, play a key role in the reproduction of physics as an elite subject by restricting then both the number and the diversity of students who feel belonging, who feel comfortable in this discipline. So through such practices, physics then is able to maintain a high status, both in relation to completely different subjects, but also within the sciences itself. So at the same time as students in this lower secondary school physics classroom are learning physics, or maybe not learning physics, they're also participating in a production and reproduction of this type of cultural notions of physics, and forming also their identities as learners of physics in relation to these physics practices. So we can actually think of, we tend to think often of learning as a purely cognitive kind of mechanism, but from this perspective, we can also think about learning as involving identity formation. Heidi Carlone and Angela Johnson, who are science education researchers, they explain this as that identity is not simply what an individual says about her relationship to, abilities in, or aspirations regarding science. Identity arises out of the constraints and resources available in a local setting. So what's possible to do in a particular physics classroom? Is it a celebrated practice to raise your hand and ask questions? Or is that rather something that's shunned upon and that you probably shouldn't be doing? These aren't things that anyone probably are telling you explicitly, but as a student, you have a pretty good feel for what these constraints are and what kind of student you can be in relation to those constraints. So they further say that identity is not just something an individual feels. It's not even what an individual does, although both feelings and actions are components of identity. A science identity is accessible when, as a result of an individual's competence and performance, she is recognized by meaningful others in the classroom, for example, their peers and their teachers, people whose acceptance of her matters to her as a science person. So in principle, what they're saying here that there are two main components to identity. Identity then from this perspective isn't just something we have or we are. Rather, identity is something we do, something we perform in relation to particular cultural notions, cultural constraints, cultural affordances. But it's not just about what we perform, it's also about the way that people recognize us. Are we recognized as that talented, clever physics student? Or are successes in physics explained by they are someone who's doing really hard work? So different ways in which a student can be recognized for the same practice, you could say. So what can this process of performance and recognition look like in the physics classroom? Well, we're going to take a quick look into an upper secondary school physics classroom. So these are older students, these are like 16 to 18, and they've chosen to specialize in science. We're going to take a look into that classroom and see what could be going on. So this is a lesson about Newtonian mechanics, more specifically a lesson about kinetic and potential energy. And the students, they've done a very, very simple lab exercise. What they've done is that they've taken a bouncing ball, dropped the ball, and then they measured the height it bounces back to every time it bounces. Many of you have probably done this. Many of you might have taught this. It's a very simple experiment. And once they've done this a few times and tried to measure the bouncing ball, the teacher in an assembly like this asks the students about the relationship between kinetic and potential energy of the bouncing ball. And one student, she quickly raises her hand, Esther. And rather than replying in words, she replies with a hand motion, showing, and I'm going to wave the microphone around a bit so I can't talk at the same time, showing how potential and kinetic energy vary as the ball bounces. So she does something like, the teacher is very happy with this explanation, very happy to see how done. As the kinetic energy raises, the potential energy is lowered. So the teacher is very happy with this. Ann-Sofie, the teacher is called, or we call her rather. She replies, that was really good. Even I have nothing to add to that. It goes like this, and then she does the hand movement again in front of everyone and repeats and talks to what Esther had said. That was a really good explanation. So this is a classroom where solutions to physics problems, they can be neat, they can be beautiful, aesthetics and emotions are recognized as important part of physics learning. And you can get recognized as a good physics student then by being able to express yourself in the representational mood of gestures rather than mathematics. So a simple sort of snapshot into what performance and recognition look like. And I think you can all kind of picture a classroom where emotions and aesthetics aren't as important as they are in this classroom. And like any other physics classroom in this upper secondary school physics classroom, some students will learn that physics is for them and will continue to higher education physics. And some will rather learn that physics might not be for them and not continue to higher education physics. Esther, she is very interested in physics, but she chose a different route afterwards anyway. I'm not going to go into that. Rather, we will look into some what I call unexpected student trajectories into higher education physics through the lens of, and here's another theoretical concept, choice narratives. Choice narratives is a way we can talk about the way we narrate, the way we present our trajectories, our choices in life. So these are the stories we tell about our way to a particular kind of education or profession as a means of justifying these choices, both to ourselves and also to others. And in this particular case, in this particular study, we have constructed these choice narratives from what we call timelined interviews, exploring then the trajectories of unexpected physics students. So what do we mean by an unexpected physics student? Well, these are students that in some way identify as being unusual in this education. So amongst them are women, it's students from migration backgrounds, it's students from other kinds of minoritized backgrounds, and it's students from non-academic backgrounds. So not a kind of majority profile of a student within a higher education, physics education. And during the interview, what we've done as interviewers is that we have, together with the students, constructed timelines outlining then very, very concretely on a big piece of paper their journey into higher education, and then marking important occurrences, important people, important events on these timelines. So this is a means of supporting these students to tell a story about how they eventually ended up in a higher education physics context. And our analysis then, it seeks to identify these choice narratives. And choice narratives, it's a concept from Henriette Holmgaard Tolstrup and colleagues at University of Copenhagen. And when they construct this idea of choice narrative, they argue that choice narratives, they need to be recognizable. That is, they need to be legible, they need to be understandable in a particular discursive context. They need to be, to some extent, personalized. There is a lot of expectation nowadays on you doing an individual, personalized choice, kind of expressing yourself through the way you choose your education, but also presented then as natural or suitable for a person and not too predictable, also coming back to the idea of wanting to have this personalized, individualized idea of who you are. And the narratives also, in order to kind of make sense, need to be presented as relatively coherent, aligning then past, present, and future. But they can most certainly be reworked along the way. So what we are seeing when we are interviewing these students, that's the stories they are telling at that moment. And that moment for these students is either early in the first or second year of their physics education. And they are studying either a Bachelor of Physics program or an engineering physics program, which in Sweden is just another way to study physics. It has very little to do with engineering, I would say. I can take questions about that later if someone's interested in the differences. So the choice narratives we identify, as I said, those are students' current justifications of their choices, and we don't know how stable these are over time. And we're going to looking at the empirical data as a whole. That is 21 interviews, 21 in-depth, quite long interviews, many of them reaching up to 2 hours. With university physics students, we see 3 main motivations for going into higher education physics. Not unexpectedly, interest in the subject is an important one. We saw that one coming. But also prestige and the possibility to make a contribution. And I will talk through these one at a time and put some more focus on the last one, which is probably the more unexpected one we found. So this is the group of students overall, with a bit of outline on their background in terms of different social categories. You don't need to be able to read the details of this. It's just to show that it's quite a mixed group of students. And we also see which narratives are the dominant narratives in their stories. So if there's a filled circle, this is something that takes up a lot of space in their stories. If it's not a filled circle, it's still figures there, but it's not as pronounced. Little wiggly things are because we aren't really sure yet, we're still analyzing those. But so that gives you kind of an idea of who these people are. I could also add that most of them are quite young, most of them are early 20s, but not all of them. There are also mature students in the sample. So first, the more expected one. Almost all the students do, to some extent, express an interest in physics. It's not a very strong narrative for everyone. But this is something that's mirroring previous research, and of course you could think that you're studying something that you're interested in. But here we also I would like to highlight that this can be of different importance to different people to really highlight how to the core important this is to you. So in physics there is a strong, we've seen that in previous studies, there is a strong idea of almost a cultural script of like the childhood physicist. It's very common for when Nobel laureates in physics write about their route into physics. They write about how they already as children were kind of playing around with physics things at home and had a laboratory in the basement. And so there is a certain cultural script related to kind of a childhood interest that then you've always been a physicist kind of idea, which may be particularly powerful for if women and minorities want to kind of claim an authentic physicist identity, you want to claim authenticity in this discipline. This isn't something you become, it's something you've always been. Now you're just refining it through an higher education. And some students, they go through considerable discursive work in order to make this narrative happen in their stories. Stella, she's doing a Bachelor of Physics degree and she's focusing on astronomy. Stella's father is working within space physics. Her grandfather was a space engineer. But it's very, very important for her to point out that her choice of astronomy has nothing to do with her parent and her grandparent. She says, people always say that you will become like one of your parents, but I don't want. I mean, like, but my dad is a space engineer. Then it's like, yeah, but then it's obvious that you're into space. But I'm like, I actually discovered this all by myself. And then she tells a very elaborate story about how she's interested in painting and she wanted to paint an astronaut for some reason. And then she started Googling on pictures of astronauts, and that's the way she got interested in astronomy. This is not me saying that her story is less true, because this is the way she's telling it, even though she has a parent and a grandparent in this. I'm just saying that she goes through a lot of discursive work in order to present her interest as personalized and individualized and not following in the footsteps of her parent and her grandparent. Students also typically recognize that physics is a prestigious education. So there are students who are not really making a choice based on interest. Because if we're making a choice based on interest, you could see people kind of choosing between education that are quite close, maybe between physics and chemistry or something like that. But there are also students who choose between very different educations, between then in particular different elite educations. So their reason for studying physics is that this is a prestigious elite education. They could equally well have found themselves in another prestigious elite education, like becoming a medical doctor, for example. Alva is one of them. I kind of decided between becoming a doctor and this, because the prestige guru in me, she says. Decided between engineering physics, another interdisciplinary engineering program, or chemical engineering. But I choose this in the end anyway, because it's the broadest and you get the most choices and prestige. Now I'm absolutely, completely honest. And then she laughs. There is prestige, absolutely, to it. So she's choosing between a variety of different engineering educations, but she also thought of becoming a medical doctor. So this is a lot about the prestige this discipline brings. And part of that prestige is also, of course, grounded in this cultural narrative physics as being difficult, being hard, being not accessible for everyone. A more unusual motivation for studying physics among the students we've interviewed, but a very strong one in the narratives where we see it, is choosing physics because it enables students to make a contribution either to society at large, or to their family, or to their specific kind of local community. Hannah talks about, she comes from a migrant background. She talks about wanting to give back, help others to have the same chance that she got. She migrated with her mom to Sweden when she was in her lower teens, and saw that she had completely different possibilities in this Western kind of context than she would have had where she was previously living. And she even has a very far-reaching goal of eventually building an institute for physics and physics education in her parents' home country, really wanting to give back in concrete terms to the community she came from. But then maybe has a bit more, not as concretely giving back to one community, but rather sees science and technology, which is one of many things he's interested in, but he could have done something else. But science technology, that is, according to him, an effective way of making the world better. So that's the reason he's doing physics. Stella also narrates her choice in relation to making a contribution, but making her contribution in a different way. She says, if someone asks, what are you doing for feminism? Then she replies, I'm a physicist. Like, I think it's quite fun. I'm here and I disturb things a bit. That's great. I'm very satisfied with that. So she wants to be a role model for other women, and she wants to steer things up a bit in physics. And whenever someone points out that she might not be doing feminist things or whatever, she just goes, I'm a physicist. That's it. So for women, there is also the possibility to make a contribution just by basically being there, being in this education. And this is, of course, also a narration that is a very much sanctioned, or being a woman in physics is a very sanctioned choice in many ways. There are lots of campaigns about more women into STEM. So Stella can also get a certain amount of sort of benefit and recognition from narrating her choice this way. And when we see this making a contribution choice narrative being narrated, it's particularly done in relation to marginalized gender, class, and or ethnic positions among the students who do this. So these are some of the motivations that we found for choosing higher education physics. But once students get to higher education physics, what do the students meet? What does the classroom look like? Well, most likely they will meet, I would say, a strong sense of community, also glued together by long teaching intense days. There are a lot of expectations to be able to perform mathematical calculations of various physical laws, but probably not as strict requirements on understanding those mathematical manipulations from a conceptual point of view. And physics also is presented to them. This is from my old physics book. It's still around, but there are newer versions of it now. This is Young and Friedman, the classic university physics. Physics is presented to them as the most fundamental of the sciences. And it's a richly rewarding adventure, appealing then to the rational intelligence, but also, like in this upper secondary school physics classroom we visited earlier, also appealing to their sense of beauty. But what might this look like in the actual classroom? How is physics presented, or should we say performed? Like you're performing an identity, you can also perform physics. How is physics performed in the university physics classroom? I'm going to give you a very brief example. This is the first lecture in a quantum mechanics course. And among other things in this lecture, the Schrödinger equation is being introduced. And throughout this lecture, the teacher focuses on how strange quantum mechanics is, how the world at the quantum scale, it looks nothing like what we're used to from our everyday experiences. And the teacher, she's just discussed that what quantum mechanics can give you is the probability to find the particle in a certain interval. We cannot know where the particle actually is. And then she says, how many find this to be counterintuitive and weird? It's a bit of a rhetorical question, but she also actually wants a reply. One student raises their hand, one student in a big lecture hall. The teacher says, those of you who don't raise your hands probably need to give this some more thought, because this is weird. So here, quantum mechanics is supposed to be incomprehensible. Don't worry if you don't understand, at least not now. And also during this lecture, we hear repeated references to Albert Einstein, to Niels Bohr, to the Nobel Prize. And all these repeated references to high-status physicists and a very high-status scientific prize can, of course, there in the physics lecture hall also create kind of a sense of that you, as a physics student, belong to something that's very special, very exclusive. So the teacher here, she can also be thought of then as kind of constructing a local physics community, a local physics culture in this classroom, where students, they are of course expected to be able to reason, because this is a classroom also very much focused on conceptual understanding. So they are expected to be able to reason and do calculations using Schrödinger equations, but they are also expected to be fascinated by, rather than frightened by, this presentation of quantum mechanics as mysterious and weird. So as a university physics student, you kind of find yourself in a world, a community, a culture, if you wish, with certain kind of customs and habits. There are certain ways to do things, there are certain ways you don't typically do things. There are certain ways of acting and being that are encouraged, that are foregrounded. There are other ways of acting and being that are less foregrounded, less encouraged. So when taking this kind of outlook on what's happening in a classroom, in this case a university physics classroom, we're trying to kind of tease out what are the norms within this community, some of which may be unspoken, some of which might be explicitly talked about. So this is then a way to look at not what characterizes men and women, or what characterizes other types of students in the classroom, but rather what characterizes a culture, and who can feel belonging, who can feel kind of find a place in this community, in this culture. And as students are then navigating and also, of course, contributing to producing this cultural world of physics, of which they are a part, they are not just then doing physics. You can also think about them as doing gender, as performing gender. And this is kind of a different way of thinking about gender than we think about gender often in our everyday kind of speech. Because in kind of an everyday understanding of gender, we probably think of this as something that we have or we are. But we can also think about, drawing on the work of, for example, Judith Butler, gender as being performative, gender as something we do, something we enact, and therefore also something we enact differently in different contexts. So you're very likely to enact it differently in the physics lecture hall than you are just hanging out with your friends in the pub or whatever. So it's enacted differently in different contexts and can be performed then through things like behavior, dress, speech, career choices or interests, or the choices you make then in your education. And I think if you think about how your colleagues, in particular if you're in the physics department, how your colleagues dress, you might think the first thing that might come to mind is we don't really have a dress code. But then you might start to realize that people tend to still kind of dress the same, maybe, or in similar ways, or that there are a few different ways to choose from, a few different ways to do masculinity and or femininity within this context. So when you perform gender, this is very much also limited by local context and to some extent also by our bodies. So from this perspective, gender is something we understand as relational. And how it also then is done differently in different contexts, that also speaks to the context as kind of enabling or limiting identities that also then are shaped by gender. And I would argue that this perspective of looking at gender, it helps us to look then more carefully at the complexities of gendered expressions in and also beyond physics environments than simply kind of asking questions about what women need to do in order to succeed in physics. Because those questions about what women need to do in order to succeed in physics, plenty of people have asked those questions, and those questions, they tend to boil down to stereotypical assumptions about how women work and how men work and how women can be in order to be more like men in this context. Or possibly how men, if they are seen as problematic students, can be more like women to succeed in that context. It can go both ways. But still, it sort of boils down to how one group can perform more like a different group, I would say. So moving away from that very static and binary view of gender can open up for questions researchers can ask then about the experiences of gender and how those vary also across different contexts. And yeah, we're going to have a look at this from also university physics. This is also an interview study. It's an interview study done in Canada. The interview is done by my colleague Alison Gonsalves, and this is from a paper we've co-published. So Laura here, she is an undergraduate physics student in Canada, and she's interviewed about her experiences of studying physics. And there is a particular focus also on gender in this interview. So Laura explains to Alison that I find it hard to talk to a lot of other women because of their interests are so far from my own that we don't really have a lot in common. I'm not interested, I barely ever watch TV and I always wear the same clothes. Like all the new clothes I get are gifts from people that people give me, you know. My roommate had been cutting my hair for the last year. Before that, I got it cut a year before, and then I might get it cut this year. Like to me, there is not just time for these things. But I find that a lot of women make time for these things. And I'm more interested in playing computer games. And like, if I had to choose between getting my hair cut and playing a computer game, I'm going to pick the computer game any day or any other game, but not getting my hair cut. I don't even like people touching me so much and things, pedicures and all, nails. I hate that stuff. Okay. So the first thing maybe to notice here on more of a kind of surface level is how Laura here feminizes an interest in caring about appearance and style, and she also positions this then in contrast to playing computer games. So on a surface level, we can definitely understand this as a doing of gender, how she positions herself then in relation to other women and to kind of a normative heterofemininity. But if we take a step back from kind of her self-understanding in the way she presents herself here, we can instead look for kind of the cultural logics that structure this utterance and also makes it intelligible. I saw a lot of you nodding as I was reading this. So what are the kind of cultural logics that make this intelligible, that makes this understandable? Well, first of all, I would like to argue that the idea that physics is gender neutral, that physics is this objective gender-neutral space, it gains strength from this type of distancing from body and style, thereby once again then privileging mind over body, and simultaneously then insisting that in physics, its reason, its rationality, its smartness, those are the only things that matter. But manifesting this neglect of body and style is also very hard to do without simultaneously centralizing the body and centralizing aesthetics. So we would argue that the body isn't here merely made irrelevant. Rather, the rejection of the body is central to making physics then appear as a discipline where only the mind matters. And secondly, students not only then distance themselves from and downplay the value of corporality and style, but in doing so also, as I said, positions these interests as being feminine. So caring about style, caring about appearance here, simultaneously then signifies femininity and not caring or not being passionate enough about physics. So paying too much attention then to style, to corporal aesthetics, is an action to kind of undermines your possibility to be recognized as passionate enough about your discipline, passionate enough about physics. I'm in no way saying that Laura are doing all these things consciously, but Judith Butler argues that, it's quite a long quote, but I think it's worth it. People are consciously or not citing conventions of gender when they claim to be expressing their own interior reality, or even when they say they are creating themselves anew. So we're always kind of utilizing these conventions, we're utilizing different cultural scripts, even though we think we are so incredibly individual and expressing our own kind of true self. It seemed to me, she continues, that none of us totally escape cultural norms. At the same time, none of us are totally determined by cultural norms. Gender then becomes a negotiation, a struggle, a way of dealing with historical constraints and making new realities. So there are these norms, we kind of need to act upon them in some ways, but we also can of course resist those and they can change. We're girlage, she writes. We're entered into a realm of girldom that has been built up over a long time. A series of conventions, sometimes conflicting, that establishes girliness within society. In the same way we can also think about conventions of physics, also have been built up over a long time. We don't just choose it, she writes, and it's not just imposed on us, but that social reality can, and it does, change. So looking at then physics as well as gender as performative, taking that kind of theoretical U-turn in your head, that is also something that opens up for change and opens up for thinking about change. And for someone who at least used to be in physics, I can say that change is definitely needed. The black astrophysicist Chandra Prescott Weinstein, she writes, I understand intellectually why my work on inflations and axioms is interesting, but I'm tired of the disjointed feeling of liking the ideas but finding it hard to breathe in the community in which I have to share them. Because I'm human and not an objectivity machine, those two things are part of doing science. Astrophysics loses so many people, including white men, because the community refuses to acknowledge this dual reality, that science is both a mathematical process and a human social enterprise. Many of my colleagues refuse to consider what it's like for someone like me to watch very few black people ahead of her in the pipeline disappear from the mix. It can be hard to see the wonders of the universe through the social card. Yet, here I am. As unattractive as the professional world of physicists can be, I'm still completely dazzled by quantum field theory. Every year I feel like I'm learning particle physics for the first time, and it's still amazing. Space-time is still curved. I'm still more fascinated by that fact than I'm horrified by all the terrible behaviors I witness from people who are experts on that fact. So the story I've told about physics today in today's talk it is a story of how physics can be all these things, how it can be dazzling and beautiful and wonderfully weird. But it's also a story of how the discipline is so strongly associated with cleverness, seen as difficult, associated with a particular kind of prestige, and how those different stories are also entangled and interconnected and shaping students' participation in the discipline. But what can we do then to make physics more welcoming? Well, a starting point is to actually acknowledge that science, physics, and the other sciences is both a mathematical process and a human social enterprise. A study by the physics education researcher Sara Hazari and colleagues, it shows that actual discussions about disciplinary culture has positive effects when it comes to encouraging female students to pursue careers in the physical sciences. So an awareness of this kind of human enterprise side of things can have also very concrete effects on women's perseverance in this discipline. In Hazari's study, this is a very big quantitative study. I have the references at the end of the talk. They, perhaps surprisingly, they were testing a number of common hypotheses as to why women pursue a study of higher education physics. And perhaps surprisingly, no significant effects were found for having, for example, women teachers or women guest speakers. But what did have a significant effect was that they, during their high school years, have had discussions about women's underrepresentation in physics class. That's the one hypothesis they found that had made, or the one thing they found that made a difference. And on a similar note, could maybe also highlighting then more motivations for studying physics beyond this cultural script of a childhood interest lead also to a more inclusive physics, a more inclusive science. A physics culture where students then from minoritized backgrounds no longer feel like they have barriers to break. Chandler Prescott Weinstein again. I wanted to be normal, but I felt I had to be extraordinary. Thank you. So, time for questions.
See? I go ahead. Yeah. So I want to express again my gratitude for your very inspiring talk. I come from philosophy, which is a different background. But I think that philosophers and physicists have a lot in common. Also, several studies have proved recently that we have the same problems. So I was wondering whether beyond changing narratives, which I find very important, there would be some ways that to find alliances between sciences because we have the same structural problems. So my concern is that if we change narratives but we don't act at the same time in structures, maybe the progress is going to be too slow for young scientists. So thank you very much.
No, I just want to say I definitely agree with that, and I think I choose to focus my talk today more on kind of the discussion within physics education research, and also trying to say some things about what you as maybe university physics teachers, as some of you might be, can do. But of course there is a lot of also non-discipline specific things, and very important equality work, for example, that goes across not just disciplines and not just universities, but probably across all sectors of society. So I'm not in any way kind of disregarding that part of it. Other questions? I think you need the microphone, so if you can pass that around. Or someone can pass it around.
Hello. Yeah. Thank you for the speech. Well, this is something very new to me. I haven't heard these kind of lectures. It's very interesting. Thank you for the speech. I just want to know, when you think of a particular topic, okay, for example, this, how do you start your research and how do you proceed? How do you gather those interesting group of students and how do you convince them to give you their feedback in the classroom or whatever? How do you think? What is your thought process like? Thank you for the answer.
Thank you. That's a very good question. I choose not to focus too much on method in the talk when I give like a normal conference talk. I, like people in other disciplines, give a long first talk about how I did the research. I mean, a lot of it is like any other scientist. You work from kind of where is the status currently in the discipline, and that's how you kind of try to find your research questions. You find your kind of take on something and finding a kind of new angle often to something that's previously explored. And then in conjunction with that, working on then developing a research design. And in education, that tend to be interviews are very common. It's common to work with observations or video recordings, also doing very detailed analysis of student-teacher interaction, for example. Or you work in collaboration as a researcher with
Only closer.
okay. Or you work in collaborations with teachers to design teaching interventions and then kind of evaluate those. So those would be some of the research methods. And for all of those, yes, you need connections you need students and or teachers. And you try to recruit those in the best ways you know, kind of. So often working through personal connections. In this case, I was visiting physics lectures, asking students if they wanted to participate. We also put up posters in physics departments and got interest that way. So a variety of different ways. Yeah, thank you.
Thank you for that. If nobody has a question, I have a follow-up question.
Okay.
So the next question is a very obvious thing. How much support do you get in terms of funding? What I mean is that compared to getting the physics faculty getting a funding from European Union and your department, how competitive is your search for fundings?
So much of our funding come from national funding agencies, so in particular the Swedish Research Council. We have a basic, as any university department, we have a basic research funding. And that is less than what you would get in the sciences, but our research is also substantially cheaper. I don't need to buy like million euro spectrometers. I just need a very cheap recording equipment. So in that way, what I need are people. I need like students and I need colleagues to work with. And when you apply then for funding, I apply for the Swedish Research Council, then I apply for a panel that's focused on educational research. And yes, that panel has substantially less money than science and technology or medicine, but that partly also has to do with, the cost of doing research in these disciplines. Yeah.
Thank you very much.
Any more questions? Yes.
Maybe do that first, you don't have to walk.
Thank you for this nice talk. Sometimes I'm thinking that this speech about gender perspective is just arriving for the people who is really interested on that. So that sometimes we are not arriving to the real people in the society, so that at the end it's difficult to introduce that. Do you have any advice on how we can deal with that problem, that we are not arriving to the people that we want to communicate?
Yeah, I think that's also it's an excellent question. It's something I think a lot about, because as an education scholar, science education, like any other researcher, I'm also continuously kind of judged around those performance measures. People aren't that interested in impact. So that's part of the issue, is what I'm expected to do from a university point of view, kind of. And that is kind of pushing my work in particular directions. But of course, reaching, in my case then, teachers and university teachers, the people who can make a change, it's highly, highly important. There are different ways in which I try to do that. I mean, giving this type of talk is one way, but I also realize that to this kind of talk, I'm very likely to, people who are very likely to be here are likely to already have an interest in the issue. We collaborate with university teachers. I have a PhD student who's working collaboratively with the university physics teacher to, together with him, try to build a more inclusive physics education, to build like higher education physics for social justice, essentially. So she is doing it very kind of practically on the ground. I think it's always that kind of balance between also showing that this is very, as in any other research, this is founded in methodologies, this is has a very solid foundation, but at the same time, you can't use all the theoretical language, because then you're going to completely kind of, people won't be able to follow what you're doing. So, yeah, I don't really have a good answer, I think, but it's a question that I think about a lot, how to reach the people who can actually make a change. Yeah.
Thank you very much.
I think you answered partially my question with the answer to the former question. So I was also wanting to know how your research is being perceived in the academic circles you are moving, because I have the impression that some of the assumptions related to the profession of physicist are constitutive and also mark a kind of exclusion. So, it is a way to recognize us as a group, as scientists, and to exclude others. So I think maybe one of the biggest problems is that to give up this kind of habits, and people might be too reluctant to behave in other ways, or to pay attention to the implicit norms in the social interaction in the physics faculty. So this is more or less my my question.
Yeah. No, thank you. Or was there a question in there somewhere?
So my question is how your research is being perceived in the fields that are people not interested in gender, for instance.
It's well, you could say that one way I'm working with this and getting it recognized is that I've in some cases been invited to, and in another case initiated a network for physicists who are interested in this type of issues. So I think that is part of my strategy, is to supporting the people within the discipline who have an interest in these issues, and who then I can support with resources, both like research results and like teaching resources. So that's the way I'm trying to reach people who are trying to themselves kind of move in this direction and are interested in issues of equity, diversity, and inclusion in higher education physics. Yeah. I also do definitely recognize and understand that there is lots of people I will never reach. There are lots of people who aren't interested in teaching at all in higher education. So then taking the step also to being interested in a form of like a more inclusive and equity-oriented teaching. Yeah, I don't see that happening anytime soon. Yeah.
Any more questions in the room?
Great.
Okay, so let me just close this by thanking Professor Danielsson. I think this has been scholarly, a very interesting talk. but also I think it's a political positioning of the Faculty of Physics, and yeah, we hope this statement does not go unheard.
Well, thank you once again for inviting me, and thank you for participating in the discussion.